So we're recording here. I've given two main lectures split up into parts on the basics of R, an introduction. So watch those first, and then I'm going to walk you through some of these R scripts that I'm sharing with the class. I'm not going to go over every single line. I'll leave that up to you, but I'm going to touch on some important parts. Okay, so this is R intro underscore lab. We start out, there's two packages that are needed to run all of the lines of this code. So if you don't have them, run these install packages and lines. If you have done this already and you're running it again some other time, you know you've already installed the packages, just comment those lines out because we don't want to install the package again if it's been installed already. It will just confuse R. So I've already installed the packages, so I'm going to comment those out with this hashtag symbol. Let's check our working directory. It's my desktop. That's not ideal. So I'm going to walk through how to set your working directory again. We did this in the lectures. You go to session, set working directory. We're going to choose a folder on our computer. Whatever folder you want to use. We used this before. We open, and you can see in our console that this command was run. If we want to save that into our script, we can either copy and paste, or let me move my face. We can go to our history and we can highlight it, send it to source. Source is our script. Sending it over there. Okay, it's there. So this, if we saved it, it would be in our script next time we came. So when you're using R, I'm sure you've seen, we can have variables and we can assign a value to those variables. And when we do that, this variable now has a data type or class. So if we assign a number to this variable X, we can check the class, and the class is numeric. We can assign a character string to our variable, and now the class will be character. So check the different data types and make sure you understand what they mean. Here are some lines of code for string operations. Maybe we want to know how many characters, how many letters are in our string. We can use the nchar command. There's grepl. I don't know. So this is asking, does QW exist in my string? If we want to understand what grepl is doing, we can do this question mark function, and it will give us the help page for this command. We can have two character strings and we can paste them together. So it's combining var1 with var2 and separating them with a space. I really recommend using this assigning character to set your variables. Equal may also work, but it's not recommended. You can go the other way around. As long as your assigning character is pointing in the way you want it to do, we can assign 5 to some var by going backwards. I have a number of these flow command sets. I encourage you to run through those and understand what these if statements are doing, what these for loops are doing. As you do that, I suggest highlighting the whole chunk and running that. And understand, based on these inputs, why are we getting these outputs? So think through that logic, make sure it makes sense to you. Same thing with these for loops. you could run them one line at a time, but it's going to run the whole chunk. So I recommend highlighting the whole thing right off the bat so you are in control of what's happening and run that chunk. Now look at it, try to understand, why is this for loop doing this in my console? So think about it. Make sure you understand why that is happening. I talk a little bit down here about matrices and data frames. So a matrix is just a two-dimensional storage of numbers or characters. It cannot be both. So we build up some matrices here. And then we build a data frame. And so remember what we said in the lectures, that a data frame is like our table that we think about all the time. It has different columns, and each column can be a different type. So we can have a column of characters, a column of numbers. Go ahead, make this. We are building a data frame of these three measures. We can look at that. So this is our data frame. It's also in our environment as data frame example. If we clicked on that, it pops up as a table. So measure 1 and measure 2, they're numeric, and names is a character string. We can check what is the size of this data frame. It tells us the number of rows and the number of columns. We can check what are the data types of every column in our data frame. And it shows them here. The measure 1 and measure 2 are numbers. Names is a character. If we go back, build this data frame again, and we're going to set strings as factors equals to true. And this is going to force any character string column to be stored as a factor, where R knows that it has a set number of levels, and it tries to put those levels in order. Alphabetical order, not always ideal, but let's check what are these types now. And we can see, instead of being just a character, names is now a factor. And it's a factor with 5 levels. These are our 5 patient names. So that is what we would do if we want to make sure that these patient names are factors. Alternatively, you could build the data frame and then set this column, our names column in our table. We're going to factor it directly and save it back to our original table. There we go. And now we check again. And this is another way to factor that column, by factoring it explicitly with a line of code. Those are factors. The nice thing about factors is they have known levels. And so if we were to look at this, it tells us the levels are patient 1, 2, 3, 4, and 5. If we wanted to flip these around and have the patients ordered in an opposite way, we could add here levels equals. So we're going to start a character vector. We start with C and parentheses, have these in 5. Four, patient 3, patient 2, patient 1. Gotta make sure to spell everything correct. Okay, so this time we are factoring this column as part of our table, saving it back to our original table, but also setting the levels in the order that we know would make more sense. So let's check them now, where the factor levels are going the other way around. And if we were to, we do a table here, they are going from 5, 4, 3, 2, and 1. Only because we had the foresight to set our levels in this way. So there are going to be times where you need to set the levels in a certain way because it makes more sense for plotting, for statistical analysis. So be aware of what are the orders of my factors and do I need to change those levels? Okay, so moving on to the next section, we're going to load this data into our environment. It's called tooth growth. I think it's part of this ISLR2 library. Okay, so we've loaded tooth growth. Let's look in our environment. It's right here. It says it's promised. It's going to come. It's going to be there once we want to use it. So watch how it changes when I run this tooth growth. So it loaded it in. And now we have a tooth growth table. This is something to do with like hamsters or guinea pigs, and they're measuring how much these animals' teeth grow with different supplements. It's either orange juice or vitamin C. Why we care about these teeth growing, I don't know. But we've loaded this table into our environment, and now we're going to write the table to some files in different ways. So I encourage you to run these 4 lines of code and take a look at those files. Go to your working directory, open up these text files, and understand the different things that are going on with the different options that you set up for write table. So here's the file that gets created. We're saying whether we want call names, whether we want row names, what's the separator going to be, and whether we want to put quotes around strings. So these are slightly different with each run. And so try and understand what's going on here, okay? Here, we've already written these files, and we're going to use this read table command to read the text file in that we've created. Do that one, and we're going to read the CSV. I told you that read.csv is a specialized form of read.table, and it assumes, it has as a default, the separator of the file you're reading in is going to be a comma. And that's why we're reading in our CSV that we created up here. So we run that too. And so now they're over here in our environment. I know they look exactly the same because we wrote them to be the same. So check those out. See the examples of how to write tables, how to read tables, and understand how some of those options matter. Okay, so the last few things we're going to do is check out the data types, the variable types of our table, our tooth growth table. We have 2 numericals and 1 that's a factor, because we asked, please make sure all the strings are factors in our table. We can get a summary of the table. I really love the summary function because it takes any numerical variable and it gives you those simple stats to give you an idea of what is the distribution of this variable. And then for any character variable, it's going to give you a count. This is just like if we did a table of one of those columns. We see there are 30 OJ and 30 VC for this sub variable. We can get the same if we do a table of just this sub column. We see the same information. We could make a box plot. So we're going to relate length to supplement with this little twiddle. It's also a tilde if you ever learned Spanish, but it's on your keyboard just under the escape key if you're looking for it. So we make a box plot, pops up over here. Move my face. Okay, so it's a box plot. It's using base R. You can also check out the relationship between length and dose. What does that look like? So there's 3 different doses, and these are the box plots for each one. In the second one, length is a numerical variable, and dose is a numerical variable. But since we're using it as the second part of our equation in our box plot, it's treating dose as categorical. You'll see here. Let's see, tooth growth sup. It's already a factor, but its order is OJ and VC. Here, we're switching it around. And we can see now it's VC and OJ. And that we'll follow through into the box plot where it will plot VC first and OJ second. So we've talked about data frames, we've talked about variables. Now I'm going to introduce to you two really important table processing applications. So the first is merging. We're going to create two data frames, data 1 and data 2. I'll pop those open. Here's data 1. We have a measurement. Data 2, we have another measurement. And you can see the subject for these two tables is the same. So what I need to do for my data analysis is to merge these two tables. We're going to use the merge function. If we wanted to check out the help for merge, it's right here. It tells you we need an X table and a Y table, and you need some sort of way to connect the tables. So we have data 1, that's our X table. We have data 2, which is our Y table, and our by is the subject. Since subject is the same in our two tables, we can just use by equals subject. And we're storing it back into data. You can look at that. If the columns in your two tables were different, then you would want a by.x, which would give our X column that we want to connect on, and we could have by.y. This is the same in this case, but if these column names are different, we wouldn't have to name them here with by.x and by.y. This gives us the same thing because our tables are the same, but think about that. If your column names are different in your two tables, but you want to connect on that column, specify your X column, specify your Y column, and R will know what to do. We could set the subject as row names. So let's look at our data 1. I uncommented this line and this line. So in these 4 lines of code, we are setting that subject column to be our row names, and then we're removing the subject column. Let's look at our data 1 and data 2 now. You'll notice that instead of having a subject column, those values are now our row names. So comment out those values just so it looks like my example and run those lines of code. And then when we merge, we can either say merge by row names, or we can say merge by 0, because R knows that 0 means row names. Run that, and we can run that. Looks exactly the same. So there's something I will point out is when we merge by row names, we get this new column that says row names. That's annoying. There's a way to do this where it doesn't do that. But what I always do is I say row names of data. I want to be this capital R row names column. So I've assigned the row names to be this column. And then I'm going to set this to null to remove that column. And now data looks like what I want it to do. There is a way to merge and do this row name assignment and take out this column all in one line. You can look that up if you want to. but I can never remember it. So I just do it with 3 lines of code, and I can type that out faster than I can go back and look up that one-liner. So try to understand, what are we doing when we merge two data frames? We need to think about what columns we can connect, and then look at the table that you get out of it and think, do I need to modify this in any way just to make it look nicer? So that is using the merge to combine data frames. Okay, the next thing we're going to talk about is reshaping data frames. So sometimes you have long data. We're going to make that. This long data, we have a couple of different rows for our subject A. For subject A, we've had a control measurement, we've had a condition 1 measurement, and we have a condition 2 measurement. And there's these 3 measures for those 3 things. Same for subject B, same for subject C, and subject D. Now, this is a very efficient way to store your data. But what it makes it hard to do is to have row names in your table. So if I uncomment this line and I say, make the row names of long data be my subject, and it's going to give us an error because you can't have duplicate row names. So it's not going to work at all with our long data format. If we formatted the data differently, we're building this data frame, we're going to look at it. This is our subject ID. And you can see there's 1 row for every subject. And we have our control measure as a column, our condition 1 as a column, and our condition 2 as a column. So columns for our measurements rather than rows for our measurements. And this has the added benefit that we could make the row names be our subject ID. If we look at it now, these are our row names, and they're out there. So if we wanted to take subject out of the bulk of our table, maybe we wanted to do some math with it, or we want to take subject out. So it's possible when you have a wide data format. If you want to go back and forth from wide to long or from long to wide, install this Reshape2 package. We're going to load it. Load this library because I've installed it already. Now this library is in our packages. Okay, I'm not gonna, maybe Reshape. All the way down. So, okay, there it is. Reshape2. And we see it's been loaded into our environment. It's ready to use. So to convert wide to long, we're going to use this function called melt. Let's take a look at the help for it. It's not a very useful help, but if you're using melt for the first time and you want to understand what are the requirements for it, go online and look where someone has actually built a real usable command of it. Or you can just look at my command. So our data is wide data. Our ID variables, the numbers, the row, let's see, the columns that have our identifying data this is going to be our subject and our sex. Those are the values that are going to be repeated in our table. They're not measurements, but we need to keep them around. Those are our ID variables. Our measure variables are these numerical control condition 1, condition 2 values. And that's going to be a new column that we're naming condition. And then we pull out these numbers, and that gets put in a new column called measurement. So think about which columns need to be repeated subject and the sex columns, and which columns need to be sort of collapsed because they contain our measures. And that's what we're setting up here. So we run that, and now we have subject and sex. They're kept just as they are. And then condition is our repeated measurement name. And then measurement is the actual number of our measurement. And it looks just like this long data that we built up here. We want to go the other way around. We start with long data. We use this dcast function. And dcast, it's wanting our long data table. It's wanting, so this is like a formula setup. We are taking subject and sex. Those are our groupings. And we're relating them to condition, which is right here. And we're telling it we want our measure to be this measurement column. Our value variable is measurement, and that's what's going to fill our table. So we run that, and now we have our newly built wide data frame. It looks just like the one we made up here. Here, with our wide format, we could do some sum. We're adding our measurements, and we're creating a new sum measures column in our data frame. Now, that's something we could do. We couldn't do that in the long format. We could filter our wide data frame. We could select some measures that are less than 30. So what did we get with that? We get one record. We could create a new column called sum split and use this if else function and say, if sum measures is greater than or equal to 30, set that value to be high. Otherwise, else, set that value to low. So let's run that. We'll take a look at it. So now we have this new column where we're categorizing our measure sum. There's one that's low, and there's 3 that's high. So think about what form would make it easier for you to use your data. This long format, it's good for plotting. For this wide format, it's good for doing calculations with your data, maybe filtering, categorizing. So one format is good for some reasons, and the other format is good for the other reasons. And now you see the commands needed to go back and forth. Okay. Close these, and I will talk about our other R script. So when you're done with your R script and maybe you're going over to something else, go to your environment, and if you see this little broom, this broom will sweep your environment. There, you click it, and it's going to remove everything from your environment. We say yes, and now our environment is clean. So open up this visualization plots RMD. So this is an R markdown format. And so you can see here's our YAML header, and here are our code chunks. It's a very simple R markdown, but there are code chunks. So as you're running this, you can run chunks at a time. So I run that one. I run the second one, which is going to load these libraries. If you don't have these packages yet, install them before you load the libraries, or you're going to get an error. So check to see if you have them. If you don't have them, look up how to install them. I know ggplot2 is in CRAN, so you can look up the install command for that and do a search for R Color Brewer as well. Figure out which command. Do you need to use CRAN or do you need to use Bioconductor? That's the most important part. Okay, and then I'm not going to go through all of this, but go in on your own and run through these lines one by one. It's in the plot. No, it's not. Okay, so since we are in an R Markdown object. These plots, they're not going to be plotted in this window over here. They're actually down here in the in-between space. When you run plots or any tables in an R Markdown, they get printed in the in-between. So run these lines of code and look to see how they're different. So I have a lot of examples of making different kinds of histograms, for example. So these is our histograms. These are the ggplots versions. That is not very nice looking, but there are different options for making plots. If you wanted to see all of these plots that were generated by this code chunk, we could highlight all of this and run it. And you can see there are plots being generated down here. In this in-between section, you can click around to different ones. Now this makes it harder to understand. This command makes this plot. I don't know which one it does. So run it one by one to really understand what makes this line of code different from this line of code. So you need to run it line by line to really see what's going on. But once you do that, if you want to just run them all and click back and forth to see the nice pictures, you can do that. Another way, so let's do the next one. Another way is if you've clicked through all of these and understood all of the lines of code to make different versions of scatter plots, and you just want to populate all of them, click on this triangle, which will run your current chunk. You can see it run through. And they're all down here. So all of the plots generated by this chunk of code are getting run and generating all of these plots. So let's say you've run all the lines of code one by one. You've run the chunks because you wanted to see all of these plots and click around and look at them. Oh, I will say, I said in the lecture that I would show an example where it had to calculate the sum of the values. So let's look at this table. This is a built-in table in R. It looks like we don't see it anymore. It's all about cars, and you can see all of this information. It's a data frame. But if we wanted to collapse all of the information about class, so there's a class for each record, and we want to collapse that information, we can use table to see there are 5 different records for a 2-seater, 47 records for compact. This is counting all those instances of class. Now, if we were to run ggplots and set the stat to identity, it wouldn't really know what to do here, because when you say identity, it's just expecting to plot the number that's in the table already. If you see in this example, we don't specify identity. It's actually whatever the default is. I don't know what the default is for this. But when we don't say identity, it's going to know we need to count. Let's see. Okay, so I'm not seeing a really nice explanation of this, but when you need to count what's in your table, do not specify your stat. Then R just knows what to do. We have our 2-seater, our compact, our midsize, all of these types of cars, and we see an idea of how many there are. So that's my one new thing that I wanted to talk about. So let's say you ran through all of these lines one by one. You really understood what each one of these plot commands are doing. Maybe you want to just run the whole thing and you get your report out. You click on knit. So this is going to run every single line of code. Is it doing it? Yeah, it's doing it. Okay, so it's gonna run, you can see it's processing. It's running through all of your lines of code and packaging it up into an HTML. I tell you to run every line of code on your own first, because if there's any code in there that throws an error, then this knitting is going to fail. It will tell you where it fails. It'll say a line number, and you can go to that line number and figure out why is this failing. So check to make sure all of your code runs, and then you can knit it. I wrote this code, so it's gonna work. But let's say it's loading this library, ggpub_r, but you don't have that library installed. It's going to throw an error right here, and your whole HTML will not get generated. It's going to quit knitting and throw an error for you. Okay, so this is the visualization, R Markdown, plotting every single plot that I have in this script. I'm trying to showcase a lot of the different options, but they're all here. And so you can look at these and try to get an idea of what makes one different from the other. The other thing that I want to show you right before I go is that R graph gallery that I talked about in the lecture. It's a wonderful resource. So if you go to chart types and maybe you're interested in making a box plot, it's not going to hover for us, but here's a box plot. And it has information about box plot. And we don't want ads. Okay, so it has some examples of base R box plots and ggplot2 box plots. So if you just want a basic box plot, you could see it here. Maybe you want to color your box plots in different ways. That's here. Do you want to split your box plots by group? That's here. This is faceting in a box plot. I think it's very useful. If you have your groups, rather than splitting them side by side, you could have all of one group in one facet and all of the other group in another facet. And those options are here. So you could click on this and you could see there's group box plots. And here are the examples of how to make a faceted box plot. Yeah, I think you'd have to run this box of code to generate your table, to plot this grouped one, and then try this line of code, these lines of code to make these two tables. That's the kind of thing. Run the examples, and then you could tailor it to your own code. Okay, so this is my lecture going through the code. I encourage you to download the R scripts and run them on your own and really understand what they're doing. Okay, thank you.